Hey everybody, let's talk about the ideal gas law, and let's talk about maybe the final, one of the final manipulations of the ideal gas law, and this is finding density, finding the density of a gas, or finding the molar mass of the gas. Now this comes directly from the ideal gas law. Okay, PV equals nRT. Okay, so I'm going to show you how this works, and then we're going to go from there. What we know is number of moles. Okay, that's like molar mass, and I'm going to use the script M as my molar mass symbol just because it's easier, right? Okay, and that is grams, that's mass over the number of moles, N. So if I were to solve this for N, this can be converted into, and I'll do it in red, that N equals M over the molar mass. The mass over the molar mass. So I'm going to take this and I'm going to do what we call a linear substitution. I'm just going to take that and put that right in there. So now, when we do that substitution, we get PV equals M over M times R times T. Okay, well that doesn't look like this. But now what we can do is multiply both sides by M, because we don't want to divide by M, by molar mass. We want to keep multiplying. So I'm going to take this, I'm going to multiply both sides by M, and so that cancels that out. And so now I get an M here. Now I'm going to divide both sides by V, and that cancels our V out. Now, here's the funny thing. What is M over V? M over V is density. Density equals mass over volume. So if we get mass over volume here, that is equal to density. So our formula, P script M, P times the molar mass, equals dRT. And this only applies to the gas. Okay, so we don't have, or we don't know. We don't know. It would be different if it were a liquid or a solid. That we would have to use our classic, put it on the balance, find the mass, get the volume somehow. Okay, so let's look at a problem where we're trying to calculate where we're trying to calculate the density of carbon dioxide. So look at this. Here's our STP. That's a good sign. So let's write what we know. Standard temperature. So temperature equals 0 degrees C, which also when we convert is 273 Kelvin, and the pressure is equal to 1 atmosphere, and that is our standard unit. And now what else do we need? Well, it's PM equals dRT. So this, I guess I should have written it as capital D. Okay. And so let's see. So if we're going to find density, we need P, M, and T. So let's find M. The molar mass is equal to, of carbon dioxide, now that's CO2, so that's C, there's one of them times 12, and oxygen, there's two of them times 16, so 12 and 32. So the molar mass is 44 grams per mole. Okay? And we are trying to find the density. Density equals question mark. Let's go ahead. Now we plug it in and chug along. So 1 times 44 equals D, we don't know that one, R, still the same R, 0.0821 times T, temperature, is 273. So 1 times 44 is 44. And then so we're going to take that 44. Let me call up my calculator. Okay, 44. And then we're going to divide by both things. So 0.0821. So we can either put it in parentheses and keep it on the bottom and do that, or I'm going to divide here, and then I'm going to divide again by 273. Does the same thing. Okay, and so I get the density of carbon dioxide equals 1.96. Now, what's the units of that guy? That's in grams per liter. Okay, we need to make sure that we have the right units, grams per liter. Now, the second part of the question, and I get rid of my calculator, it says, is it less dense or more dense than air? Well, I give you air. It's a comparison problem. Okay, that this guy, 1.2, is definitely less than 1.96. So this guy is definitely less. This is more dense. The density, CO2 is more dense. Now, the interesting thing is what does that mean? So what? Well, let's say there's a fire in your house, right? Okay, things are burning up. When things burn, they release carbon dioxide. Okay? And so carbon dioxide, if you're in a room, okay, there's going to be smoke up here, but carbon dioxide, when it burns, is going to be found close to the floor. The air is what's going to be found here. So you got to be careful when you're crawling around in a fire, because CO2 on the bottom of the floor, you can suffocate because of carbon dioxide. Okay, but then you don't want to get too high because the smoke's going to be up here. So you don't want to die of what they call smoke inhalation. So air right in the middle. Okay, life is pretty cool. Also, let's say, and a lot of these have to do with fire examples, but okay, there's a demo where I can put a candle in a beaker, but then I cover the beaker. Okay, or the flask. This is a flask. What's going to happen? Okay, well, what is going to happen is, because it's on fire, it's going to run out of air, but it's going to be replaced with carbon dioxide. So the carbon dioxide is going to fill this up until this guy goes out. You need oxygen in order to burn. The air is going to be up here. The carbon dioxide is going to displace the air. And so it's kind of an interesting little thing going on here. So that's all the stuff that we can get from these problems when we compare densities. So cool. Have a great day and enjoy density.